2025 Advanced Higher Maths paper by SQA, which is now known as Qualification Scotland. Let's get straight into it. Question 1 then. Binomial theorem. If you look at your formula sheet, you should see this thing here. It's relatively straightforward. Just plug in 1 over x as a, minus 3x as b, and 4 as n, and you should get this. You do have to know how to calculate 4 choose 2, but it's given right here, so it should be doable. Simplify, and you get this as your answer. Question 2 then. It's just quotient rule. Your top function is 2x cubed plus x, and your bottom function is 3 plus 2x. Just shove it into the formula. It does say simplify your answer, so if you expand out the brackets, collect like terms, you get this. Question 3. Two complex numbers are defined as 11 plus 10i and 3 minus 2i. The 0w is just this thing. You want to rationalize the denominator, so you times by the complex conjugate of the bottom thing, which is 3 plus 2i. Expand out the terms, you get this. Obviously I squared is minus 1, so this becomes plus 4, this becomes minus 20. This simplifies down to 1 plus 4i. Good. Question 4, part A, is literally just adding. Pretty straightforward. As your final answer. Part B, A transpose is this thing here, because to get a transpose of a 2 by 2 matrix, you take the first row, here minus 3, 2, and that becomes your new first column. So minus 3, 2 is your first column. And your second row, 0, 1, becomes your second column, so 0, 1. So A transpose B is this, and then when you multiply out, you should get this. So that is part I. Part 2 then, find an expression for the determinant of A transpose B. Well, the determinant is given by this thing times this thing minus this thing times this thing. So that's that. And that actually gives you the mark, but you should probably simplify it further. Part 3 then. A transpose B is singular when the determinant is 0. 30 minus 6 lambda is the determinant, so when this is 0, lambda is 5. And that means A transpose B is singular. Good. Question 5. Just let u equals 2x. This thing becomes u squared. Differentiate this. Rearrange for dx. Your integrals turns into this. You should know that 1 over 1 plus u squared is just arctan u. The 1/2 is outside the integral, so it becomes 1/2 arctan u plus c. And then u is 2x. So just shove that back in there. And that's that. Question 6. This is suggesting polynomial division, so just set it up. You could also equate coefficients if you wanted to, but it's probably easier to just do polynomial division. So you do that, and you end up with this. So A is 1, B is 3, and C is minus 11. Now, in part B, state the equations of the vertical and non-vertical asymptotes. A vertical asymptote will appear when this blows up to infinity or minus infinity, and that will happen when this bottom term gets very, very close to 0, and then this becomes 11 over something very, very close to 0, which becomes very large. So x equals 2 would be your vertical asymptote, because at x equals 2, this becomes 11 over 0, and then you're tending towards infinity. As for the non-vertical asymptote, as x gets very large, this term becomes smaller and smaller, because you have 11 over a term that is getting very, very large, which gets close to 0. So as x gets very large, f of x approaches x plus 3. So your vertical asymptote is at x equals 2, and your non-vertical asymptote is at y equals x plus 3. If you look at Desmos, you can see at x equals 2 is a vertical asymptote. It tends towards infinity and minus infinity, and as x gets bigger and bigger, then f of x approaches x plus 3, which you can hopefully see if you just imagine drawing x plus 3. It starts looking like it. Question 7 then. There's two ways you could do this. You could use the integrating factor, or you could just separate the variables. But the second method is probably easier for this one. So just get all your y's and x's on upper sides. Integrate both sides. 1 over y becomes ln y. And 1 over 2x minus 1 becomes 1/2 ln 2x minus 1. Because when you differentiate ln 2x minus 1, you get 2 over 2x minus 1, so you need 1/2 of that. Using some log rules, you can simplify this. So if you just bring this coefficient into the power, and bring this c into the ln by writing c as ln e to the power of c, and then ln a plus ln b equals ln ab, you can move the c into this ln. It looks something like this. From there, do e to the power of this side equals e to the, this power here. So you get y equals this. From there, you want to solve for a constant term. So you just shove in x equals 5, y equals 12. And it's relatively straightforward to find c. C is ln 4. And then e to the power of c then is e to the power of ln 4, which is just 4. So your final answer is this. Final question then. Part A, use Gaussian elimination to find t, the point of intersection of the three planes. It's pretty straightforward. Here's your matrix. You want these two terms in these two rows to be 0. So if you just do row 2 minus 2 lots of R1 and row 3 minus 3 lots of R1, then these should become 0. So if you do that, you get this. Hopefully you can see quite nicely that the last row, if you take away a copy of the second row, it will be 0, 0, 7. So minus 7 and then 7. So that gives you this. And then from there you can do backwards substitution to find x, y, and z. So just solve for those. And that means t is 2, 4, minus 1. That's what solving for. Part B. Find P, the point of intersection of the line L1, the plane pi 3. How you do this is you write the line in parametric form. So you write it like this, where this is all equal to some parameter, like t, and you rearrange and solve for x, y, and z respectively. So now each value of t corresponds to a point in L1. But if you just plug in these parametric expressions for x, y, and z into the equation of the plane, like this, we can solve for a value of t that satisfies the equation of the plane. So it lies on the plane, and it also corresponds to a point in L1. So if we just do that, we can find t equals 2. And that means you can solve for the coordinate because, well, x equals 3t minus 4, so x equals 3 times 2 minus 4 is 2. Y equals 11, z equals 6. So that's your point of intersection P. Final question then. Find in parametric form the equation of the line L2. If you want the equation of a line, you need a point on the line and a direction that the line points in. So 2 points that lie on the line are T and P. And since L2 is a straight line, the direction of it must be the same as the vector TP. So that is just 0, 7, 7 if you just do T to P. And then any point on L2 will just be a point on the line L2 plus some multiple of this direction vector. So you can use any point L2, but I'll just use T. So any point L2 satisfies 2, 4, minus 1 plus some multiple, where k is just a real number of 0, 7, 7. So that means you can write it in parametric form. So x equals 2, y equals 4 plus 7k, and 0 equals minus 1 plus 7k. That's about it.